guys online and to meet you. We were thinking that we can take questions today and do the session for questions and answers. So please ask questions. I'm really happy that Steve could join today as well, and we'll be happy to answer your questions.
If you're afraid to speak up, you can try typing it into the chat. That's a possibility as well. But if you're very bold, you can turn on your camera and just ask a question. It's quite fine. And we're a friendly bunch. Nobody wants to go first.
Yeah, how's the course going? How's the homework going? How is the materials?
Got a question, maybe.
Yeah.
Oh, no, we don't. That's Professor Montalban. I'm nudging them.
Is everybody excited about virtual reality? What kind of headsets are you using? Okay, first. Okay, so the first comment is that first I had to revisit linear algebra from decades back. That's good, right? Linear algebra is pretty helpful.
Yeah, then dive into C#. What's next? Nuclear physics. That's not bad. Well, what other subjects are coming up that they have to dive into?
Physics is going to be in optics.
But basic light, I guess.
But it's very basic. Yeah.
Lenses and light propagation and stuff. So not nuclear physics, but some basic physics.
I'm guessing calculus. It will be more towards the end when we're talking about tracking systems. Yes.
But it's more about understanding what velocity and acceleration are. So it's back to like just a little bit of physics. It's not really having to do complicated calculations like integrals or chain rule derivatives and all. It's not all that kind of stuff. They're not going to be doing any of those kind of calculus calculations. So don't worry about that. But everybody's rusty on those after doing it a long time ago.
Yes, a little bit of neuroscience, very little.
In psychology, quite a bit, right?
Oh, physics engine for CBB programming skills. Physics engine. We in this course we don't explain how to implement any of that.
Yeah, most of the game industry physics engines aren't really true to physics, right? They just make stuff that looks good for games. So there's a big question about whether you want your physics engine to be high fidelity, true physics, high quality, especially if it's interacting with multiple objects that are falling on top of each other and such, or do you want it to just kind of look good? And I think a lot of things that look good on a screen might not look good in virtual reality when you're actually interacting with them. So things that were good enough quality for a game might not be good enough quality. So that leads to a lot of potential opportunities.
Yes.
Okay, someone found a tutorial on quaternions by Weizmann Institute, very useful. Also a 1985 paper by Schomke. Okay, well maybe you can put that in the chat or some link to it or something, or figure out another way to share.
OpenGL, Vulkan, API.
Yeah. Not something I mess with, but heard of it. Like which one to use? I don't know. I don't know what that question is. OpenGL and Vulkan.
Like which one to use? Oh, okay. Well, depends on what you want to do.
Yeah, that sounds like a generic AI kind of answer, right? Well, it depends. Of course it depends. It's not an easy thing. I think OpenGL is really ancient and it's kind of the foundation of almost everything. So Vulkan is.
People really use, a lot of people use just game engines like Unity physics.
If you want to do your own low-level optimizations on GPUs and stuff, then I guess you start getting into Vulkan. If you're going to write your own physics engine, maybe you'll be doing something like that then. Not something we provide in the class, but this is more fundamentals. And
Right. This is not something that we cover in class. Unfortunately, as you mentioned, virtual reality is such an interdisciplinary field that there's so many topics, and we just mention them briefly, but don't go in details. So physics engine is one of those things that we don't cover, obviously. But yeah, I guess I never really, in my experience, had to use physics engine either. So Steve is looking at some.
you know, like sometimes people have like
Do you
this.
want to share your screen, by the way?
No, like I'll just put it in the chat. Like this is some toolbox that was supported by TRI, Toyota Research Institute. But I mean, this is some robotics friends of mine's made this one. But I mean, that's a context where they want very high level of physical realism. So that's different than game industry kind of stuff. It really, and it's, you know, in virtual reality, you have to ask yourself really, what's the context? What do you want to do? And then if you wanted to make some kind of high performance thing, then, you know, who's going to do that? Who's going to work on the coding very close to the GPU with the right kinds of, you know, whether it's Vulkan or whatever you're working with. Takes a lot of skill for that. A good knowledge of physics and a lot of skill. And a lot of tricky kind of things that happen with numerical problems and all sorts of things.
Yeah.
Okay, currently learning.
Unreal Engine 5.
Yeah, learning Unreal Engine 5, and I made basic games. How do I transition to AR, VR? Yeah, oh, thanks for the tutorial. That's at least some more information there. Great. Well, I think transitioning to AR, VR is what's the difference between looking at stuff on a screen versus wearing a headset and having some interactive control mechanism and such to be able to do things. So I think that's in some sense, the transition is what the course is about, right? In some sense, I mean, because the course isn't phrased as a transition, but if you have that background, that's great. You might want to unlearn some of the things you've learned from just doing, say it's like a first-person shooter type experience, a game or something like that. It's easy to map all the geometry over and just all of a sudden put it in virtual reality, but it might not be appropriate in virtual reality. A lot of the kinds of motions that occur might be sickening or frustrating. When I was at Oculus, when we were both there, very early on, they started porting a bunch of games that were designed for, you know, just regular PC with a big screen. They ported it over to VR. It was easy to do the port. You know, they could do it within a couple of weeks or something. But then making a good playable game that's comfortable in the long term and fun and everything was really another kind of question. I'll give you an example. There was a game called Team Fortress 2, maybe you've heard of, but from Valve, and we were cooperating with Valve, and they put it on our headset, some version of it, and then we had a game competition night, like networked game competition, where people could play against each other. And some of the people were using PCs, and some of the people were using the VR version. And it turns out the VR version people got crushed. They lost to all the PC people because the PC people could move around with the keyboard and mouse and the screen. And the interaction mechanisms were much more refined there, and the experience was much more refined. So their kind of kill rate, let's say, was much higher than for the people in virtual reality. So it wasn't really a kind of compatible thing, and it didn't really take off as a kind of a big thing. So it really suggests that you completely redesign what kind of experiences you're thinking about and such. And that starts from understanding the human perception side and understanding about sickness problems and all sorts of things like that.
Yeah, so in short, I would say the most challenging part of the transition is going to be interactions. If there was some kind of interaction library, I think at some point we were even thinking of building an interaction library ourselves, then it would be more easy for you guys with cardboards to implement any kind of reasonable game right away. But there are no such libraries, especially for cardboard. So for high-end HMDs, there are some interactions that you can already use provided by Oculus, but not for cardboards. So essentially, there is nothing that helps you, or nobody that helps you to create interactions in virtual reality in cardboards, and you have to do it yourself if you want to have any kind of meaningful experiences implemented. And what we can help you with is just the content of this course, not more, because otherwise we would have to sit down and spend a lot of time implementing something like interaction library.
It took decades to develop the game engines that you're essentially using to make these experiences, but those were made for games on a fixed screen. So everything's guiding you in that direction. And that took decades. So it's going to take some more decades to have really the right kind of development tools to make it easy for people. But you're smart students, so develop your own tools, do your own things, but you'll have to build some stuff up from scratch. It gives you a lot of opportunity for creativity, but it's also risky. It may fail, and you have to find the way, just like people did a long time ago, leading to the game engines that we have today and the whole industry, game industry that exists today.
I can give you a simple example. I was working over the summer with a student, and we wanted to do a very, very simple game. It's a multiplayer game in a cardboard where two players can bounce a soccer ball around. And then a lot of questions arise regarding interactions. Okay, how are you gonna move on a field? And the student did what he did. He implemented continuous motion over the field, which is completely against any kind of best practices that we teach in this class, because continuous self-motion without any physical self-motions is creating optical flow that may lead to nausea and discomfort. So this is unacceptable. But then it's very challenging. How do you actually implement the way players would move over the soccer field? Or how would you implement the way the players interact with the soccer ball? So all of that is very difficult and challenging, and requires numerous iterations back and forth and trials in trial and error kind of scenario of implementation. And the thing is, we don't really have answers. You really just have to try. And this course hopefully will nudge the development of these interactions in the right direction. So. Okay. Yeah, I hope I answered.
Is anyone brave enough to turn on their camera and ask us a question face to face? That's what we're hoping for. That's our goal. Someone will be the first, right? And not Professor Mani. He's already brave enough to do that, of course. So he doesn't count. I wish we were there in person, because then I know people would not be so shy. I know this video online format is kind of awkward, but anyway, we do the best we can.
Actually, if you guys don't have questions, it would be nice to bounce the ideas of how to implement interactions in cardboards. Steve is here too. Maybe you didn't spend as much time thinking about this kind of questions, right? Like, what do you do if you have 3 degrees of freedom interface only, 3 degrees of tracking system that you guys have? About my one eye.
Okay, well, don't be shy about anything. No, there's no problem. We're all friends here, but it's up to you, of course. No serious pressure, just gentle pressure.
Hi, Steve and Anna. Avinash here.
Hi.
Hi. My question is like,
Hi. Nice to see
you. It's like not much technical, but in general, right? XR field, like the future prospects and other thing on the XR application. The way we see, right? Like Apple Vision Pro and all this thing, right? Not so successful because of this end user experience and all this thing, right? So is it right time to invest the time in like creating application on XR and all this thing, or it's too early in market?
Yeah, I think that's the $1 billion question, or $1 trillion question, maybe. We all kind of wonder this, and I've been wondering it for the last 10 years. It looked like it was the right time in 2014 when Oculus was bought by Facebook for $3 billion, and then Oculus or Facebook since then or Meta has invested $100 billion or more, and many other players have. But the thing that I find frustrating is they still can't come down to just a basic, lightweight, comfortable headset. That it doesn't have to do all the fanciest things or have the highest in graphics, but I think they're very motivated by the video game industry, which kept progressing by just doing higher and higher fidelity graphics all the time. And I don't think it has to be like that. But yeah, I know what you mean. It's sort of like, should we get into computing when we're still using vacuum tubes and no one's invented the transistor yet? It's like a lot of the problems of making the devices really mass produced and low cost and lightweight and all these things have to do with nanophotonics and optical engineering, and these are really hardcore physics challenges. So the joke up there about physics, it actually is some really hard physics that remains in the way to solve these things, and it's hard for a bunch of people to jump into that. There's a very small number of people working on that, and it's very, very challenging. So I don't want to give the easy, yeah, it's the right time, or no, it's not, but that is a risk. And it seems the devices are getting better, but I wish they had gotten better over the last 10 years at a more significant rate, or at least that people are trying to make different kinds of devices. You see some glasses, but they say, oh, look at these AR glasses, and all they do is take pictures. And that's not too exciting. Or maybe it's just a fixed virtual screen in front of your face. It doesn't have head tracking. It's like, well, yeah, that's kind of fine. I would rather see like a easier, like less demanding kind of virtual reality headset that's lighter and doesn't have as much computational demand and things like that. But they're not going to, I don't know why they don't make it. They don't seem to get that. They have their own priorities. By now, they've tried many other things and failed, so you think they would try it. And of course, the interaction mechanisms remain. So if you're going to be more of a researcher type, then of course it's an excellent time to be getting into these things. If you want to be more of the scientist and researcher. If you want to start a company and go make some money really fast, then you'd have to really pay attention to the numbers. How many headsets are people buying? Whose hands are they in? Do the analysis of the market and that sort of thing, and really make sure. Now, with these cardboard kind of solutions, that definitely gets it into people's hands. So if you can make a compelling enough experience, then that can provide a good gateway, and hopefully these better and better devices will come along later. But I was surprised that these cardboard things can already do quite a bit. There needs to be something that's kind of in between, like a little better than cardboard, and doesn't have to be as fancy as these, $500 headsets and stuff that are huge mass on your head and stuff like that. It doesn't have to be like that. There should be things a little better. Maybe that's the right thing to do, to try to, start a company that makes things that are a little bit better. But it's hard going. It's very challenging.
Yeah, the question is, what is your company going to do? Is it going to be doing hardware? That's really difficult, optics stuff.
Mm-hmm.
Or is it going to be doing software, but then for which hardware? For cardboards?
Yeah, you're right. There's not a the easiest no-brainer thing that so many people have made billions and billions of dollars off of is just putting an app on the smartphone ecosystem, right? It's already there. You make some app, it doesn't even work very well. It helps you like order pizzas or whatever it does, and somebody gets filthy rich from it, right? And it looks like that's the way to go. Woohoo! This is a very early stage of a new kind of platform, and it's really hard to say what it is. The platform, and does it look more like Hollywood productions or Bollywood productions or Collywood productions, whatever, or does it look more like the video game industry, or does it look more like something else? Is it more like a workplace productivity? People aren't even sure really. So, and then I think there's going to be probably different kinds of devices. It's sort of like imagining in 1950, someone asking the question, what's the computer good for? And if they had said it was going to replace if it was going to replace drafting, like architectural drafting with a pencil and paper, people would have thought that's the most ridiculous, ludicrous idea. I talked to the guy who pioneered that. He's in his 90s now or so, but I talked to him maybe 10 years ago. And he was explaining how in the 1960s, when he pushed for computer graphics and like revolutionizing architectural design with like having the designs in the computer, there was so much laughter and backlash against that, So it's still in these early phases where there's enormous opportunity to carve out something new and big, but it's also a lot of risk, and it's hard to figure out.
Okay, and for like just I want to mix this AI with the XR, right? So nowadays we see different tools which help to write application faster, right? For example, this WebXR or Android XR, right? All these things. So like for Android application, there's a Flutter tool, right? Which write application work on different platform. So like there's any already known AI model or some tool which help to write application faster for XR,
Well, I
AVR,
think,
or
yeah, that's a great question. I think for AI to be really helpful, it needs to be trained on some useful data, right? That kind of does the right thing. And so for like, let's say ordinary software channels, like software that gets used in the service industry or software that gets used, even standard computer graphics game engines, all that code is lying around on the internet and it's been slurped up and, sucked up by the learning algorithms. And so it's able to just, give advice on that. One of the things I like to say about deep learning is that it's like a kind of smooth interpolation between plagiarism on one hand, because it's just stealing stuff, but it's also able to mutate it and interpolate a bit and approximate or translate it into something else. So it's also just kind of smoothly blending between plagiarism and plausible sounding nonsense, and so the thing that happens in this new domain is that there's not enough good written code out there. There's not enough good practices. Most of the stuff is noise and garbage. And it's on platforms that are likely to be not very stable because they're still even trying to figure out what these platforms should be. So it's probably not a good time to just sort of expect AI to figure it out. I can guess what AI is going to say for a lot of things, and it would be probably the opposite of what I would teach to do because I know a lot more about these systems very deeply. But my data is not out there as much as everybody else's crummy, software implementations and everything else are. So.
sure. Thank you.
Yeah, bringing up AI is a very interesting point. Everybody's scratching their heads and thinking about how AI is going to change the world right now, or how is it going to change our lives. And I think it is changing our lives a lot. It can be useful for a lot of things, but in terms of learning, or how does it affect students and their prospects for careers, I think that's a different topic that is also very interesting. And I would say that before jumping and using AI for anything, I would recommend students learning some topic so deeply that they're better than AI. That's kind of the goal of education, I think. That's very important because only if you're better than AI, you're useful in that domain.
Because you're producing new data.
More than AI, because you're producing more data. Because otherwise, why somebody would hire you or keep your work, right, if you are worse than AI? So that's kind of in terms of education. Like, yeah, learning AI is great, but before that, you have to learn the topic better than AI.
I have a question for those of you on the call. Is this a problem in India right now with regard to software engineering jobs? Is the number of job openings going down? Are people having trouble finding positions because AI is writing a bunch of code? Is this happening there? Can anyone tell me?
It's everywhere, yeah.
Kind of like everywhere,
yeah.
Yeah. So, but in this domain of like VR, AR, XR stuff, there's not a lot of good stuff out there. So I think it's this is a niche where you can learn something that AI is not going to figure out.
Become better, yeah.
And hopefully but the question is, who's going to value it? You either have to make the value yourself, get your own investors, build your own company, or you convince some people inside of a big company that what you're doing is better than whatever AI plausible sounding nonsense will spew out.
Sure.
Thank you. Those are
Thank
good
you.
questions.
Thanks.
I'm glad you were able to. We see there's humans. We see there are humans on the other side. Otherwise, it could be AI asking us questions.
Yeah, that's true.
We have more questions on the chat. I'm sorry, I don't want to belittle the people typing them. It's also quite fine. If I were a student and younger, I'd probably be the one typing the text too. So, but I'm older and don't care. And I guess as a professor type, we're supposed to be in front all the time. What techniques are used to minimize VR motion sickness and enhance user comfort? And are there any AI-powered tools to assist in achieving this? Well, a lot of the stuff you go over in the course, right? So why don't you summarize some of that, and then I can say something about AI-powered.
Well, one of the main sources of VR sickness is the optic flow that does not correspond to physical self-motions. So if I sit in a chair and use a joystick to move my virtual self, then physically I'm not moving, but there's this optic flow that is one of the main sources of VR discomfort and sickness.
It's called vection.
Yeah, so it produces the sensation of vection, like, oh, I'm actually moving, and that's caused by your vision, triggering your brain thinking that you're moving based on vision feedback. but your vestibular system says, no, I'm actually sitting in my chair, right? So there's this sensory conflict that causes a sensation of action, an illusion of self-motion, and that is that's associated with the VR sickness. Nobody knows how and what is the cause and what is the result, what causes what. So scientists don't know about that yet. Nevertheless,
There's some theories.
yeah, there's theories. Anyway, so how would you minimize that?
Now, you can also reduce sickness by just narrowing the field of view,
Yes,
or lowering the resolution, or making it not as bright and colorful, like making the contrast lower. But then that makes the experience worse. So the real challenge is to figure out how to make a great experience while cleverly dancing around these kinds of problems and stuff. It reminds me of like Hollywood doing different kinds of special effects and different kinds of camera views and zooming and panning, and they do all these things that seem to kind of work, but it took them many decades to refine all of that. So it's very similar.
So some researchers made their careers just on this, like studying different techniques of what would minimize discomfort. I don't think there's like one answer yet, or I don't know about AI powered tools. Again, because there's not enough data on this.
For AI, I think for AI powered tools, there's some, so what you might imagine is feeding an experience into a system, and then it tries to predict how much bad it's going to cause. And this is very similar to, there's this thing called FPA, Flash Pattern Analyzer. And it was done to try to predict whether or not a television broadcast going back to the 1990s would cause epileptic seizures. And so they had this system that was developed by a company in England, and the FPA, Flash Pattern Analyzer, and you could feed it in and it would try to classify it. And if it basically passes that test, then you can put it on TV. And governments in UK and US signed off on it, and many other governments and things said, yes, this is okay. There was some cartoon that was causing people to have seizures and stuff, and so they had to respond to this. So the same kind of thing can be done in VR. You can call it AI or you can not call it AI, but I'm sure there's people doing like, deep learning based classifiers that are trying to predict whether or not there's sickness or the level of sickness. And another way you could do it is geometrically, just try to quantify the amount of vection, also knowing that contrast is important and resolution is important and so forth. So these kind of things could be done. So that's how AI would be used for that.
Yeah, you would have to produce data, feed it in, and then learn to predict the next experience. But unless there's data, you cannot really use AI.
Next question is, what are the limitations of current VR hardware in terms of latency, refresh rates, and field of view? That's kind of a very general question, and because it's and I would put weight in there too. I can get latency low and refresh rates really high and whatever they need to be, and I can make the field of view really wide. But then you end up with a big clunky mass on your head. And so I think the interesting question is, what do these numbers need to be to have a really good experience when that's also counterbalanced with weight and cost and these kind of things. So, and that's the kind of things I think is good to think about in this course in the context of it.
Yeah.
My sister's tech employer is convincing all employees to get their code from ChatGPT. Well, that pretty much means that they think software engineers are worthless and unnecessary. Yeah. So that's pretty.
Or they're bad. Like all of the software engineers that they can get are worse than ChatGPT. That makes sense.
Yeah.
One story that I keep telling was that as an educator, I need teaching assistants, right? And recently, I don't feel like I need teaching assistants anymore as much because I can use ChatGPT. So when ChatGPT produces something, I still have to look over and correct it, but it's not as bad as maybe some teaching assistants could be. So I'm not as desperate for that. And that's actually a bad thing, right? It's a bad thing for young students who might want to become teaching assistants. And I just don't need them anymore. So that employer, that is saying that they don't need junior programmers as much, or maybe the junior programmers that they would be hiring would be much worse than ChatGPT. That's really bad news for young people, really.
Yeah. And you can imagine a lot of older managers in companies have no understanding of all of this stuff in great depth. So they've just heard all the hype and they're like, cool, we can save money. Let's get rid of all these people and just have one or two of them just spew out ChatGPT garbage all day. And they don't think it's garbage, but they may discover that in 2 or 3 years that their entire software foundation is built on garbage. And then that's really unfortunate.
Very experienced software engineers write code better than ChatGPT and faster than ChatGPT. Very experienced software engineers can tell which code is written by ChatGPT and which code is not written by ChatGPT. And therefore, very good experienced software engineers are still needed, and they still can easily get a job. My brother, for example, he has been a postdoc at MIT. He's working for Boston Dynamics AI company right now. He can always get a job. If he loses his job, he will get a job because he writes code better than ChatGPT. So that's something that we kind of, as I said, we are all figuring it all out, how things in life is going to change after such advances in AI. But it's very important for you, younger people, to know that you should become better than ChatGPT in software, in coding, in VR.
And that's for particular problems of interest, because
Yeah.
most of the ChatGPT stuff, like I said, is largely plagiarism. So some very, very smart people wrote some code that's free. It's open source. Now ChatGPT can spew it out and claim it as its own. So it doesn't necessarily mean that you have to be like the best of all coders that have ever existed. But in a particular context, VR, AR, XR is one of them. You may be able to do some things that are the right thing to do that people have missed before, because AI is not going to know these fundamentals of perceptual psychology and these kind of things and sickness and take that into account when it spews out some code. It's just going to steal and adapt and translate a bit. We should probably go through more questions.
Yeah.
Do VR designers have to account for a blind spot and how to avoid placing game objects in certain locations? Well, the particular blind spot that's due to your kind of retinal attachment is I've never seen that as an issue so much, because your head's rotating, your eyes are moving, and these kind of things. However, there is an issue if you have like a panoramic view, and if you're making a kind of mystery game or some kind of experience where you might want them to look in certain ways. Then people have experimented with you doing acoustic cues, or maybe even little flashing, blinking lights in the periphery, so that or blinking pixels essentially in the periphery, so that it triggers you to turn your head and look in certain ways. So you can provide subtle cues to get them to look in certain ways. Let's see. We got 3 questions.
How will advanced AI affect the realism of That's a good question. AI definitely can help with the realism and characters, because there's so much data with photos and videos. So that's really good. If somebody wants to do that, that's easy to use AI and do some meaningful maybe work with that.
What I like to look at is the power of human imagination. So how high fidelity does it all need to be? And I think it doesn't necessarily have to be the highest, but it is an interesting question in general to think about how far it needs to go to be indistinguishable from reality. In 1980, if someone heard a tape recording of something like, say Richard Nixon in the 1970s in the U.S. doing some criminal activity in the White House, the Nixon tapes were enough to cause him to lose his job as president and almost go to jail. He should have probably, but anyway, he got pardoned. But in nowadays, if someone heard an audio tape sounding bad recording of someone saying something, you'd never believe it. You'd be like, oh, come on, it's so easy to fake. Then came pictures. People, oh, there's a picture of someone doing that. Well, yeah, but that's so easy to fake, Yeah. Now it's so easy to fake a video. So it'll be interesting to see how far it has to go to where, oh, I saw it all in VR. It was real. It was really happening.
Yeah, I really felt it all.
You're like, no, that's fake too. The whole point of VR is to be fake. So.
But there's the next questions like, will advances in photorealistic graphics make VR indistinguishable from real life? And that is so far away from happening, really, because the smells.
It's just hard to get all the fidelity up.
All of the senses.
Well, more senses, and the graphics itself is nowhere near the right. I mean, if that's the goal, but I don't think that's necessarily the right goal, at least not in the next 10 to 20 years. I wouldn't say in the shorter term.
Oh, indistinguishable from real life. Sorry, I felt like fully real life, but because the next question is true full body immersion in VR. And I was like, there has to be so many more wearables. Like, I can't even think of what should happen so that we really have the sensation of the whole body.
Everyone wants something like the holodeck from Star Trek or something, if you know these kind of things. But that's I don't know. It's quite a lot of breakthroughs, I would say.
A lot of breakthroughs.
Big Four accounting firm, yes, that's right. The accounting firms are going to be just want ChatGPT garbage for a while until they figure out what a mess they've made. It'd be interesting because a lot of the math might be wrong in those accounting things, and it'll take them years to figure it out. How does NVIDIA frame generation work? How it creates frames? NVIDIA says AI. How can an AI run on a single GPU? I don't know the answer to that. I don't know what an NVIDIA is doing, so I don't have
Up
close
to date on that.
I don't have close context there. That's a good question, very interesting, but I don't have that.
That's
I tried some AI assistants in Unity, such as the cursor plugin for Unity. Really helps in automating basic tasks. That's good. Yeah. I think judiciously using AI in the right places can save you time. Even one of these master coders, like one of Anna's friends, is on the steering committee for all of C++. He's a Finnish guy. What's his name again?
Ville Voutilainen.
Yeah, Ville Voutilainen. And so he's but he says he still uses ChatGPT to just bang out some initial version of the code, so he doesn't have to type every single keystroke in. We used to call that copy and paste, but if it bangs something out, like cutting and pasting or copying and pasting, it starts off as a good template, and then you know exactly what you're doing though, and you know exactly how to fix it, you know exactly what to suspect is wrong, then it's fine, because it's just saving you keystrokes and time and stuff. But if you're doing it without any understanding of how the language works or what all the subtleties are, then you're just making a mess. It's just garbage in, garbage out, pretty much. So, so I think it's fine. How can VR be integrated with? Is that global information systems and remote sensing? Is that what GIS is here? I'm going to assume it is global information systems. Geographic information. That is the right term. Yes, thank you. Geographic information systems. I haven't heard that word in a while, but I used to know it. Yeah, it makes perfect sense. I mean, there's all kinds of great visualizations one can do.
It should be integrated.
But I mean, what's
a nice application, right?
Yeah, I mean, obviously, take something like Google Earth and make a VR version of it that doesn't make people sick and gives them a sense of presence. It'd be great to be able to visit a city virtually,
which is already possible,
and have good memory that I've been there, and like have a good sense of what it's like, so that if I actually go there, I'll be like, oh yeah, I've been here before. I know what all this stuff is. I know how it's laid out. It all makes perfect sense. A lot of different types of jobs where that would make good sense. And that's part of remote sensing as well, because there's all kinds of, grabbing the data from all over the place and visualizing it, or maybe it's high fidelity sensing where you're building up 3D maps and models and things. So it makes very good sense. How can it be? I guess we just said, yes, it can be, and that's a good idea. There's a lot of complicated technical challenges in there. A lot of it is, I think algorithms from computational geometry have been very useful for GIS over the years, and they'll have to be adapted and extended and pushed even harder in this kind of context of virtual reality.
Yeah. Is this format okay for you guys to ask questions? Because it's a lot of fun to us, for us as well, to talk about these things and kind of brainstorm.
Yes. We hope you're all smiling.
Yeah. But coming back to AI and using AI for help us figure out how to implement virtual reality experiences in different ways. A year ago, when we were developing your course, where we would teach you how to use virtual reality remotely, that is, we knew that you will not have any high-end HMDs that we would provide to you, and you would have to calibrate your own cardboards and implement experiences on this very limited systems. I was really sitting down and thinking, what can we ask you to implement in this very limited setup? Because I didn't know any interactions that were, so back to interactions again. I didn't know anything interesting that you could achieve with this kind of systems in 3 degrees of freedom. So you could only look around, I guess, and not interact with the environment unless using gaze. So of course, ChatGPT already existed last year. So I asked ChatGPT, what are possible interactions in 3 degrees of freedom systems? And the answer was gaze. That's it. Gaze, or maybe some buttons that you could click. So AI could not provide any kind of help at that point, other than that was already published on the web, right? That's why I think really, if you want to advance this I don't know, this field, I guess, and make some improvements in our understanding on how to use virtual reality in these settings, then it's really your job, not the job of AI. AI will not figure out anything beyond what's already have been discovered. So for example, twisters that we teach you in this course, that's something that we have discovered, and that's a small step in creating meaningful interactions, but maybe there is a lot more things. Maybe there's kind of gestures that you could sense and create some meaningful experiences. So that's another kind of comment on the use of AI.
One of the comments here is that the person who asked the question about the GIS and remote sensing is that they wrote a story for National Geographic on Second Life. One person spoke about how this was the future, and you could walk through virtual streets and info would be available on every building, street, et cetera, and gazing.
Yeah, that's really nice.
Yeah, that's right. That's been a vision for a very long time. And people with AR glasses and pushing those kind of things. So yeah, you'll walk down the street and all the information will be there kind of overlaid on the buildings. And if you cannot remember the names of your colleagues or whatever, they'll appear above their heads and all of this kind of stuff. So, yeah, it is the future. The question is just when and on what kind of platforms and devices. I think it's really funny. Around 1980, I can't remember the exact year, but around 1980, there was some news articles in the United States about how wasteful it was. I think it was the University of Utah made some graphical system that would go around through a town in Colorado, and you would drive around and you would see where the buildings are located, and you could go from one place to another, and it would even maybe plan your route. And it was like a very old version of Google Maps, like Google Street View with the driving and all that stuff. And nobody, it was cited in the article as an example of a waste of government funding, doing something so stupid and ridiculous. And it ends up being, something we just rely on every day. It's just normal stuff now. I think that's pretty interesting how these things change. So that was the future. It just took maybe another 30 years for that to become normal. So.
Also, what would VR really bring different than what we already have? Because we have Google Maps, and it kind of also labels all of the things that we need to discover along the route or whatever. It's really helpful in navigation, and because you can ask for directions. So once you add virtual reality to the picture, what would it really add, right? And what can it add without having the hardware for it? So maybe the hardware is the bottleneck, not the data, because there's already a lot of data that could be put on the right hardware, and you would have just like what you described, right? So the hardware is the limitation. There's no, like, the form factor, the heavy bricks that are sometimes even wired, and then your blindfold. So that's really the limitation here, the bottleneck for that to come true.
Hi, Steve and Anna. Can I add one more point on the AI component of it? Yeah. So, yeah. So, when we offered this course now in the past years, there were a lot of questions, even in the online. Now, there were a lot of questions from the students, and but nowadays, in this course, although we have 8,000 students as registered students, the number of questions is actually reduced. So I believe this is an effect of AI. So maybe the students are finding the answers for all the questions in the AI, or no, what do you call it? They are not getting the questions, and we are explaining it very well. So what do you think?
And if they're getting their answers from AI, I kind of worry that they may believe that they've gotten great answers, but they might not have. Yeah. So this is like a reducing the natural curiosity to ask questions when you're encountering experts or people who are really experts on the subject. If that's no longer valued, that's and instead just a quick AI answer is preferred, then people may forget about that. That's really scary. Thanks, Mani. That's terrible.
That is a very good comment. Because it's true that we see less students in our classrooms, and that could be the effect of AI, because maybe students feel like coming to lecture is a waste of their time where they could find the answers faster using AI. But then again, what is the quality of those answers, right?
So maybe we can ask a question that that the students have to find questions that AI cannot answer.
Yes.
Okay, that could be an exercise. Yeah, exercise homework for in the each of the lectures that the students have to find out questions that AI cannot answer, right? That will be very, very difficult, I guess. So that also will make the students think what is already known, what is already that the AI will answer only that is already trained with, that is already known with, right? So if AI should not know the answers, then you know they have to ask a question about the recent things that AI doesn't know, right?
Yeah.
That
Yeah.
maybe we'll have to somehow nudge them to think instead of depending on AI.
Yeah.
Absolutely.
But even if you go back just a few years, you could say, is the thing I want to know about on Wikipedia already? If it's already on
Yeah.
Wikipedia, that means a lot of people know about it, but
Yes.
if Wikipedia didn't have the answer, it probably means, you need to figure something out. So now it's much broader than Wikipedia. It's just everybody's code and everything anybody ever wrote is this there. All libraries have been scanned. So it's like great, but you're still just recycling what's already out there. So
Yeah.
I think it can be very intimidating for young people because when we give this advice that you have to become smarter than ChatGPT in some topics, if they haven't experienced how dumb can ChatGPT be on topics that haven't been discovered, just what we were talking about, then they may not believe that it's even true. It may seem that ChatGPT is so smart and so powerful that it may be feel impossible to become better than ChatGPT on some topics. So I think it can be quite intimidating, really. And it's very sad. So yeah, A2, by the way, it's true. We really want to know your name because you have been asking very good
mysterious
questions.
A2. Maybe A2 is AI.
Oh my God.
AI2 improved.
So he's saying that he was researching, or she was researching into info on a topic for which all records are only in dusty libraries or unscanned. And ChatGPT just made up fantastic sources and realistic looking links.
Yeah, that's
Yeah, I've seen that happening many
Yeah.
times.
Yeah, how do we encourage the students to ask more questions? So offline also they are not asking questions. Now also see we are getting very less number of questions. We want to encourage the students to ask more questions. How do we do that?
No.
That's a very good question. But I think one very good idea that we just talked about was to find a question for which ChatGPT will hallucinate something. And I think I have an idea, and maybe that could be the task for the next live session. Why don't we find questions for which ChatGPT will hallucinate different answers each and single time? And one possibility would be to ask any kind of three-dimensional puzzles, like what would be the representation of some even head orientations in quaternions? Ask ChatGPT that, like some questions that you can compute exact answers, and see if ChatGPT can do that, because it's really bad with 3D geometry. It's terrible with 3D geometry. So many questions that you have about 3D geometry on your quizzes, just see if you can make ChatGPT answer some, like make up some answers. So let's do that for the next time. I think that's a good exercise. Like test the limits of ChatGPT or any other AI assistant. Does that sound like a good idea?
Yes, they're all thinking about it.
Yeah.
Yeah, I think it's a good idea. Let us implement it in the next live class.
Yeah, let's try.
Because
I'll try to prepare some examples. That would be really nice. Okay.
All right. Well, sorry we couldn't be there in person. I would love to get some vada, idli, uttapams, and all that good stuff,
Yes.
but we have to suffer through our Finnish food here.
Well, we miss uttapams, vada, and idli so much that I had to learn how to make our own
I hope
uttapam.
you are making now. I hope you are making there.
It's waiting for us. Yes, We'll have dinner, uttapam dinners today.
Wow, okay. With
Yes.
sambar and chutney and some.
I have to make sambar, so I still have an
Wow,
hour
okay.
for dinner.
Yeah.
Yes, please, A2, send us an email as well. We want to know who you are. Oh, I'm so sorry to hear about your accident.
It's all right. We all have problems. Different things happen, it's okay.
Yes. Okay, so I think we're done this time, but we'll be happy to have another session in the future and join it. It was really nice to talk to some of you directly.
All right. Take care, everybody. Good luck with your studies.
Sure.
Yes.
Thank you. Bye.
Okay. Bye.
Thank you, Steve. Thank you, Anna.
Yes. it
And
was nice.
yeah,
Yeah.
next live class also, if it is possible, if you can join, it'll be amazing.
Yes, yes.
And we
Finally,
will
finish
encourage you.
vacation is over, so we're back to work. It was a long finish,
Right.
you know.
Yeah.
Yeah. Bye.
All right.
Okay.
Take care. Bye.
Thank you.
Bye.
Thank you all. Thank you, students, all those who joined and asked questions. Take care. Have a nice and safe weekend. Bye.
Thank you, sir.